ممكن يصير في عندي كراك. ما بعرف شو يعني بيعني بالكراك، ما هيك ولا لا؟ حدا بيقول لي شو بقصد بالكراك؟ احنا كم طالب يا شو اسمه محمد؟ ما هيك محمد معنا ولا لا؟ محمد مندوب الصف وين؟ معنا مندوب الصف؟
ايه دكتور، ايه.
صوتك واطي. لا حدا بيعرف شو بقصد بالكراك ولا كلمة جديدة؟ ما هيك؟ كراك يعني بالعربي شو بدي اسميها بالعربي؟ حدا بيساعدني بالعربي شو يعني؟
تشققات.
كراك يعني بصير مثل شو بنسميها بالعربي؟ والله ما بعرف.
فسوخات. طيب
نعم.
فسخ.
طلعها، حطها على التليفون، طلع بالعربي شو بنقصد فيها فيك؟ شو بنقصد بكراك؟ هات لشوف لك شو في كراك حتى لا إذا قلت تاني مرة ما يكون في تشرخ. شو يعني تشرخ؟ فرجينا نشوف شو بيقصد فيها الكراك. كراك يعني مثل، خليني أقول تشرخ، مش هيك؟ هذا بدنا نقعد نفسر شو يعني تشرخ بالعربي. عندنا مشكلة. كراك حط لي إياه كراك كمان، نسيتها. ما ظبطت معه. تشرخ يعني بصير في عندي مساوئ، يعني تشقق، فينا نقول تشقق يعني. فإذا كان في عندي هالcompatibility condition do not satisfy، هتلاحظ في عندي separation بين كل particle. separation يعني كأنه في عندي مناطق فراغ inside the body, and therefore properties تبع البادي will be of course decreasing. Right, and that's what I mean by compatibility conditions. Then I will move to chapter 3, and as I said, بما انه في عندي say for example movement of the particle from one position to another position due to the applied external load، هيك بما انه في عندي movement، فاذا صار بدي اطلع الفيلوسيتي، acceleration and so on, and also the trajectory. velocity and acceleration of any particle moving from one position to another position. And we will try to derive relations and equations. And of course, tensors will be used to represent the motion and the flow of these particles from one position to another position, in which velocity and acceleration, rate of acceleration, rate of velocity, how these can be, say, for example, represented and determined in this chapter. And as I said before, if we have external loads applied on body, so internal deformation will be occurred, and therefore stresses will be developed. And as I said, stress by definition is force divided by cross-sectional area, right? يعني if you have steel bar subjected to tension force, the force applied force divided by cross-section area of the bar هتعطيني شو هو stress, and that's what I mean by stress. فإذا because we have deformation, so we have stress. So we need also to know what are the stresses applied on anybody, internal stresses due to the external applied load, type of load or forces which are applied on the body, relations, how these can be used, and all will be expressed in the term tensor. And let's say, for example, we have stress. Stress can be represented. We have several types of stress, as will be seen. We have normal stress, we have shear stress, we have flexural stress, and so on. And in this case, we have to go back slightly to statics course, because in static course, you remember when we consider a section in order to calculate the internal forces. We have normal force diagram, we have shear force diagram, and we have bending moment diagram. And if, say, for example, you want to continue, you may also have torsional moment diagram. So moment that produce torsion on the member. So we need to, at any section, if we have normal force, so we have normal stress. If we have shear force, so we have shear stresses, and so on. So this normal stress can be along the X, Y, and Z, or it can be any normal stress has 3 components. Shear stress has, depends on the cross-sectional area, so it may have 6 components, and so on. So all these were presented in the form of tensor, as will be seen later. So at this stage, we know how to, due to anybody subjected to external load will be subjected to internal deformation, internal stresses. We need to find out how to determine these deformation and stresses and how to relate these together. Right? In the next chapter, we will try to use theory of elasticity in order to relate the strains or the deformation and the stresses. And we have several equations that relate to this, and therefore, if you have, say, for example, a deformation, so you can calculate the corresponding stresses and so on. So this is, in brief, will be the course which we are going to study in this course. And you can see it is continuous. It is a continuous of course statics, static course, but studies the internal deformation, internal equilibrium. Statics كنا ندرس external equilibrium صحيح due to applied external forces. مثل ما في عندي equilibrium equation be static due to external applied load, هتلاحظ في عندي هون كمان equilibrium equations that relate the internal deformation. And we will see this how. So in the same way, يعني another way, if say for example a body, we have a body subjected to external load, after the application of the load, the shape of the body will be changed. صح؟ فإذا هقول أنا before deformation, this is the shape of the body. Sorry, before application of the load, this is the shape of the body. Say for example a cube. After the application of the load, after certain time t, ممكن ياخد any shape. ممكن يصير في say for example losange, say for example ممكن يصير عندي ellipse and so on. So we need to find the deformation after, or the deformation after the application of the load, and the corresponding stresses that are developed due to these external forces, and how to relate these two properties together. This is in a brief description what we are going to study in this course. Because we are trying to provide or give this course to be general, so we oblige it to put it in mathematical form. And as I said, it will be useful for all disciplines, most important for civil engineering and mechanical, and less important for students who are going to go to electrical or petroleum department, right? Any questions before I start with the first chapter? So this is the main course, and this is very important for any student to know the objective of this course in order for us to know at the end the outcome of this course how will be, and in order for us to understand what I'm going to do. نحن كم students يا محمد؟ عندك فكرة؟
لا دكتور.
نعم. الصف كم واحد انتو؟
ما بعرف العدد 100%.
نعم. صوتك واطي مش مسموع.
عم اقول لك ما بعرف العدد 100%.
لا تقريبا، يعني تقريبا قد ايه؟
تقريبا يا 80 يا 90.
معقول؟ نعم.
تقريبا.
وفوق تقريبا. بس علي صوتك بعيد.
فوق ال 80.
80. أنا حاضر 53 54 والباقيين.
مع دكتور نصهم عندهم مشاكل انترنت.
نعم.
وكهرباء. نصهم عندهم مشاكل انترنت وكهرباء.
يا عين. طب كيف هنتعلم اونلاين؟ يعني مش عارف كيف هنتعلم اونلاين اذا كان ما في لا كهرباء ولا انترنت.
هلا هو عادة نحن بنعمل ريكورد للمحاضرة.
بس
مش قادر
يعني لا لك يعني ما بعتقد انه التسجيل بينفع، يعني ما كثير، يعني لانه حيسمعني هو وقاعد عم يشرب نسكافيه، واخر همه اخر شيء بينطر الاكزامبل ليجي لحتى يعمل مثله، وبعدين بالنهايه بيطلع عندي النتيجه مثل ما بتطلع معي النتائج بالستاتكس.
بس هو هيدا الحل الوحيد افضل من ما يحضرش بالمره.
نعم.
هيدا افضل حل، انه احسن ما يحضرش بالمره.
نقدر نعرف كيف يعني. ماشي. I will try to start with the first chapter اللي أنا سميته mathematical foundation, and in this chapter I will try to define what I mean by continuum mechanics. Continuum mechanics deals with physical quantities which are independent of any particular coordinate system. So it is a physical quantity which are represented with the term tensors, but these quantities, in order for us to be specified, it is always represented relative to coordinate system, to certain coordinate system. Mathematically, such quantities are represented by tensors. A tensor may be classified in a particular coordinate system by a certain set of quantities known as component of this tensor. And if you know, say, for example, this quantity relative to certain coordinate system using transformation law, so therefore you can find the component of this in any other coordinate system. وهي بسميها يعني transformation law, and this transformation law can be considered as certain tensor. Yeah, let's say, for example, if we have a vector f represented with respect to coordinate system x1, x2, x3, I'll say x, y, and z, right? If the same vector can be represented with different coordinates relative to another coordinate system, say, for example, x prime, y prime, and z prime. And this is what we call it transformation law. How to represent, because any particle, as I said, inside the body will be subjected not only to translation, it will also be subjected to rotation. Not only, as I said, depends on external loads. فإذا بهالحالة I will use the term tensor to represent certain quantities, and these quantities will be represented relative to certain coordinate system. This coordinate system can be orthogonal coordinate system, can be spherical coordinate system, can be polar coordinate system, and so on. Depends on the actual body in which the applied load is subject. We have several types of tensors. We have general tensors and Cartesian tensor. What I mean by general tensor, if say, for example, in the case of general coordinate transformation between arbitrary curved linear coordinate system, the tensor defined are known as general tensor. يفهم ده؟ فهمنا شيء ولا لا؟
لا
حد عم بيجاوبني ولا ولا ما عم تسمعوني؟ أنا مش سامع حدا، ما حدا عم يحكي.
عم قول لا ما فهمنا.
الصوت كتير واطي من عندي، يمكن من عندي، بس خليني اشوف. الصوت واطي. انا موطي عفوا. ماشي، هلا انا احسن. انا بس جيت قلت مثلا هون اذا جنرال كوردينيت جنرال تنسر، مثل ما فهمنا هلا هي التنسر هو عباره عن مجموعه numbers or quantities, and these quantities will be used as certain properties of the bodies. And these properties أو يعني say for example مثل ما قلت يعني لو كان عندي deformation أو say for example body subjected to translation, so this translation has a component along the x, y and z axis صح؟ فإذا هذا عبارة عن tensor consists of 3 components, and these components هن deformation أو translation along the x, y and z. صح ولا لا؟ كمان ممكن يكون this body subjected to deformation ولكن it rotates. So كمان ممكن هو يكون عنده rotation relative to x, relative to y and relative to z. So therefore these are another 3 components. These are components of the tensor. In this case, any tensor in general can be scalar value, can be a vector value, or can be a matrix. وعبارة عن several group of numbers that are used in order to define certain properties of the structure. Right? We have general tensor in the case of general coordinate transformation between arbitrary, يعني if say for example you have a transformation, let's say for example you have a vector represented with certain orthogonal coordinate system, and this vector transferred relative to another coordinate, say for example polar coordinate system. So if the transformation matrix which is obtained through this transformation from orthogonal to polar or cylindrical coordinate system is called general tensor, because they are transformation from one coordinate system to another coordinate system, and that's what we call it general tensor. Of course, when we make transformation of certain properties. On the other hand, we have Cartesian, another tensor, we call it Cartesian tensor. And by definition, when the transformation occurs from one homogeneous coordinate system to another one, which is also homogeneous, يعني if you transformation occurs between certain orthogonal coordinate system to another coordinate system, as I said, so كأنك عم تعمل rotation بالcoordinate system certain angle, so this is called Cartesian coordinate system. So the tensor involved are known as Cartesian tensor. Of course, the type of tensor that should be used depends on the application, depends on the body, and therefore, so it depends on the body. So we choose the Cartesian tensor, which one we need to use. طبعا in this Cartesian tensor or coordinate system, orthogonal coordinate system. When I say the word tensor in our study, I mean Cartesian tensor unless it is specified otherwise. Right? خلينا نروح أكتر بالنسبة للتنسر. في شيء بسميه أنا tensor rank. What I mean by tensor rank يعني whether can be zero order tensor, first order tensor, second order tensor, third order tensor, fifth order, fourth, and so on. What I mean by how tensors are represented. Tensors are usually classified by rank or order according to the particular form of this transformation. It depends on the number of components. خليني أعطي several examples to this. Thus, in a three-dimensional space, in 3D problem, the number of components of a tensor is presented 3 to the power m, where m is the order of the tensor. 3 to the power 0 شو بيطلع عندي؟ بيطلع عندي 1، يعني بيطلع عندي tensor composed only of one quantity or one number such as scalar value. Right? صحيح ولا لا؟ أنا قلت التنسر will be presented to any value. فإذا أنا عندي هون tensor of zero order أو zero order tensor has only one component, 3 to the power 0 equal to 1. And typical example هو scalar value. لاحظ, and as I said, tensor هو عبارة عن several quantities used to represent the properties of the members or properties of the body. Scalar value can represent anything. Tensor of first order, if n equal to 1, 3 to the power 1 equal to 3. And typical example as a vector. Vector has 3 components, right? In space or in 3D, vector has 3 components, and vector can represented by a tensor, first order tensor, and their component, handle component of the vector, right? So tensor is not a scalar value, is not a vector, is not, but it is represents the quantity or the number of components that represents of. إذا عندي أنا V1 هي component of the tensor, V2 component, and V3 component. So therefore V هو vector can be considered as first order tensor. Let's say for example if n equal to 2, 3 to the power 2 هو عبارة عن 9 terms. فإذا this second order tensor always represent 9 terms in 3D problem and can be a matrix or can be a consecutive 9 numbers or 9 quantity. What they are represent depends على السيستم اللي أنا عم بشتغل عليه. واضح ولا لا؟ فإذا this is a tensor, second order tensor, this is first order tensor, this is zero order tensor, and so on. If say for example n equal to 3 to the power 3 27, فإذا هو عبارة عن tensor that represents 27 numbers or quantities, and each of these represents certain properties of the body. It can be deformation, can be stresses, and so on. When I say deformation, it includes translation, include rotation, include distortion, and so on. So we have several properties, right? Change in length in all direction, along the x direction, along the y direction, and so on. Change in the rotation, and so on. So these are what I mean by by a secant by a tensor. طبعا if the system in plan, so therefore بدل ما تكون عندي 3 to the power n, it becomes 2 to the power n. Again, 2 to the power n, فإذا 2 to the power n, if n equal to 0, also it is a scalar value, represent a scalar. If n equal to 1, هو كمان عبارة عن a vector, represented a vector that has two components. And if it is, say, for example, n equal to 2, so therefore it is a four terms, which are can also be represented by a matrix 2 by 2, right? And in this way we can represent. So that's why what I mean by order of the tensors. Can be either the number of components can be either 2 to the power n or 3 to the power n, where n is the order or rank of the tensor, right? لاحظ the tensor has several numbers or several quantities. These quantities can be represented by indicial notation. What I mean by indicial notation, يعني I'll take an example. لو كان عندي say for example A, يعني let's say for example we have a vector. Vector in 3D problem, it has a 3 component, V1, V2, V3. احنا قلنا this is first order tensor, right? بدل ما اقول كل مرة V1, V2, 3 بقول VI وأنا بعرف in space I takes the value 1, 2, 3. And that's what I mean indicial notation, right? Another example. Say for example we represent, say for example, the coordinate system by x, y, and z, or simply you can say xi, with I takes the value 1, 2, 3. فإذا هتصير عندي كأنه x1, x2, x3. with x1 هي عبارة عن x، x2 عبارة عن y، and x3 عبارة represent x3 and so on, right? فإذا لهالسبب جيت قلت in the component of the tensor of any order may be simplified and represented by the use of indicial notation. That is, say for example, for orthogonal base unit vector I, j, k, we can directly say xi, x1, x2, x3, or simply xi, right? فإذا أنا في أقول say for example this is I, j, k, or represented x1, x2, x3, or simply xi. في أحط لأني بعرف لو كان عندي البروبلم in space فإذا I takes the values of 1, 2, 3. If the system in plan, so therefore I takes only the value 1 and 2. And that's what I mean by indicial notation. And you can see the advantage of this indicial notation as will be seen later on, right? يعني بدل هات يعني several examples. AI, if I take the value 1, 2, 3, so therefore AI represents A1, A2, and A3. And this is of course first order tensor. Tij, if I take the value of I and j takes the value 1, 2, 3, then this represents Tij, and you can see the simplification. This represents T11, T12, T13, T21, T22, T23, and then T31, T32, and T33. So you change the value of I from 1 to 3. يعني you fix, say for example I equal to 1 and you change j from 1 to 3, and then consider I equal to 2 and change j 1 to 3, and then I equal to 3 and change j from 1 to 3. So these represent 9 terms, and so there it is a second order tensor. Epsilon I, j, k in the same way. So this is third order tensor and represent 27 numbers or 27 quantities. So this is first order tensor, second order tensor, and third order tensor. And you can see these and these can be either placed as subscript or superscript. And it can be placed analysis below or upward in this way. And you can see the simplification of using indicial notation in this way, right? Is it clear? We have two types of indicial notation, and this indicial notation can be represented in this way, types of indicial notation. And as I said, لاحظ انه لو كانت عندي if say for example any I equal to only takes only one value, so therefore it is 0 fourth order and it is a scalar value. If say for example I takes value takes 1 and 2, so it's two-dimensional, first order and so on. So in this case we can simplify the problem. We have two types of indices because these indices may occur unless once or twice in the term in any term. طبعا عم بحكي بعد mathematical, and these terms of these quantities will be used later on for deformation stresses and motion and the flow to determine the velocity and the acceleration. We have two types of indices, and as I said, the letter index may occur once or twice in a given term, and therefore the first type of indices we call it free indices. When an index occurs unrepeated in a term only once, appears only once, that index is called takes the value, whether say for example in plan or in space takes the value 1, 2 in plan or 1, 2, 3 in space. That index or these indices are known as free indices. Typical example of this as a vector. لاحظ أنا مثل ما قلت إنه V1, V2, V3 which are component of the vector V or the tensor V can be represented by VI. لاحظ VI appears only once. So I is a free index because it repeats only once. لاحظ إنه the number of free indices represents the order of the tensor. هون قديش عندي number of free indices إن only I 1, so therefore it is first order tensor. If we have say for example number of free indices equal to 2, so therefore it is second order tensor and so on. And another example, other examples, as you can see, this is AI plus BI. لاحظ these are repeated only once, does not repeat it, so we have only I, so this represents 3 terms. So A1 plus B1 first term, A2 plus B2 second term, A3 plus B3 second, third term. So this is also because I is only once, this is term and this is term, and it's repeated in the term. Another example, let's say for example AIJ. AIJ, as I said, represents if you change I and J from 1 to 3, or another way, this represents A11, A12, A13. These are the 3 terms. وبعدين put I equal to 2, and then A21, A22, A23, and then put I equal to 3. So this becomes A31, A32, and A33, right? So these are no 9 terms, so this is second order tensor. 3 to the power 2 هو equal to 9. So therefore كمان هون عندي يعني the number of free indices نلاحظ أن I and J do not appear more than once in this term. So I is free index and J is a free index. The number of free index in 2. So therefore this tensor is second order tensor, or 3 to the power n 3 to the power 2. So therefore it is this tensor has 9 terms. السبب فيه يقول أنا as a conclusion, the tensorial rank, the rank of the tensor of a given term is equal to the number of free indices appearing in that term. Right? It's clear. يا شباب واضح ولا لا؟ Another index or indices, we call it dummy indices. And this type of indices, when an index appears twice in a term, and that index takes the value of its range 1, 2, 1, and 2, or 1, 2, 3, depends on whether it is in plan or space, and the resulting term are summed, these indices are known as a dummy index. And as you can see, the replacement of that index by any other index does not change the value of the value of that tensor. Stays the same. Heart examples. Say for example AII. AII لاحظ I repeated twice, so therefore it is a dummy index, is not a free index. And as you can see, these indices are known as dummy, and the resulting term are summed. يعني حاول أنا if I take the value 1, 2, 3 فإذا هتصير this term لاحظ according to the previous rule اللي أنا قلتها هون في عندي I is a dummy index, we don't have a free index, so therefore it is tensor of zero order. You know, if number of free indices is equal to 0. يعني الand equal to 0. 3 to the power 0 equal to 1. فإذا AII هي represents A11 plus A22 plus A33. And of course it is a scalar value. Right? Or say for example لو جيت غيرت أنا لهالسبب قلت أنا the replacement of that index by any other letter not appearing as a free index does not change the meaning of that. If I change, say for example I to J, still this one is still dummy indices. كمان this one equal to A11 plus A22 plus A33, and as you can see this is exactly the same as this one. Does not change. But if say for example if you change the free index, of course that change the number, change the value or the quantity of the tensor. Another way, let's say for example we have UI VI. لاحظ in the term I appears twice, so therefore it is a dummy index. I dummy index. كان عم بعمل scalar product of two vectors. This is vector U and vector I. Vector U scalar vector V هو scalar values. يعني this represents. And as you can see, how represent, say for example, scalar product of two vector as indicial notation. It is UI VI, which is equal to the I value takes, say for example 1, 2, 3, and all terms are summed because we have the this index appears twice in the same term. So therefore this represents equal to UI U1 V1 plus U2 V2 plus V3 U3, which represents the scalar product of two vectors. And of course it is a zero order. In the same way, another example of this, how to define. لاحظ ان this is aij bj. لاحظ ال j appears twice, so therefore this is dummy indices, and I appears only once, so therefore this is a free index. The number of free indexes is they are equal to number of free indexes is 1, so therefore it is tensor of first order, and you can see how it is. لاحظ أنا if say for example we want to write these terms in expanded form, so this will be as follows. First term takes I equal to 1 and you sum all values over the dummy indices. يعني A1 1 B1 plus A1 2 B2 plus A1 3 B3. This is the first term. This represents the tensor of first order similar to vector. If that is say represent a certain vector, it has 3 components. So this is the first component. Right? The second component, I put I equal to 2. And then change J from 1 to 3. And this will be the second term. So and so on. So this is the first term, second term. لاحظ I put on I1 B1 plus AI2 B2 plus. Now if I equal to 2 يطلع عندي second component of the tensor. If I equal to 3 هيطلع third component. It's exactly similar to vector. Right? يعني this can be equal to VI. This VI equal to AIJ BJ. VI is a first order tensor because I appears on the other side only once. Right? Another example, let's say for example, this is a similar example. VI, UI, VIK. لاحظ I appears twice, so therefore it's dummy indices. K appears only once, so therefore it is free indices. So it is this term is a first order tensor in which a free index هو K. Exactly similar to the previous one, but I changed the right. So this is how we define the order of the tensor and the number of components of any tensor that will be used later on in the to define certain properties. Rules on indices. لاحظ أنا يعني AI and BIG. So AI قلت أنا هي first order tensor صحيح؟ و BII هو zero order tensor. So this is one number, one quantity, and these are 3 quantities. This is not possible because you cannot add a scalar value plus a vector, right? So this is not possible. This is indication is not correct, right? Because you cannot add يعني بالنهاية أنا بس أوصل AI عم أقول vector BII scalar value. So this written يعني notation is not correct and should not be used because you cannot add vector with a scalar value. You can add vector with vector, right? يعني first order with first order, second order with second order, zero order with zero order, because physical meaning of first order هو عبارة عن 3 components. If you need to add this term to any other term, it should be on the same nature, يعني the same in order for us to add. So this is not correct using it. It's not very indication of the, so this is wrong application of the indices. And this we have, of course, to take into account, into consideration when using the indication. And this is, of course, and I said does not make sense. So therefore, this is not correct indication or using of indicial notation, right? And as I said, it is possible to represent dummy indices index by any other letter, and this will not change the value of the terms and the tensor. And as I said, AII هو scalar value, AJJ scalar value, and AKK scalar value. They are equal. Right? Another example. لاحظ this is in this term we have I is a free index, J هو dummy index, so therefore this tensor is first order tensor, so this should be equal to another first order tensor. السبب this is I and this is I, this is term and this is another term. This is not all of them, it's a term, so this is term as you can see, and this is term. So the number component of this term should be equal to the number of components of this term. This is first order tensor and this is also first order. This is a free and this is a free, and therefore this represents three components. So we add all values of the J, and I represents the component of the tensor. And if I equal to 1, so therefore this is the first component, I equal to 2, second component, I equal to 3, this will represent the third component also. Right? Clear?
ما فهمت لهاي.
يعني نحن عندنا هيدا إلا وحده، هي ترم لوحده. إذا first order ولا second order؟
ايه بس ما عرفت انه كيف عم نقرا لها هيدا، يعني كيف عرفنا انه first order؟
ما قلت لك يعني الاي free order free index ولا dummy index. احنا قلنا by definition free index هو if it is repeated only once in a term. الاي كم مرة انعادت؟ مرة واحدة، فإذا الاي هي free index. الجي شو هي؟ لأنه repeated twice هي dummy index. احنا قلنا the order of the tensor equal to the number of free indices. فإذا this term is a first order tensor. لو بدي اكتب هيدا التنسر in expanded form, this will be equal to هياخد أنا ال I equal to 1 و J summit all values about J، يعني C11 Z1 plus C12 Z2 plus C13 Z3. This is the first term. Second term in the same way حط ال I equal to 2 وبعدين vary J from 1 to 3 and sum all values. يعني هتصير عندي C2 1 Z1 plus C22 Z2 plus C23 Z3 and so on. طبعا the term that should be equal should also be free index. It should be a first order tensor. The I in this term appears only once, so therefore it's free index. So this is a composite free vector, three components. This is three components, and all these are three components. I think I put it in expanded form. This is first component, second component, and third component. Or you can put it in matrix form. X1, X2, X3, Z1, Z2, Z3, and this is, this by itself is a second order tensor. This first order tensor, and this is first order tensor. إذا بدي آخذ الترم هي لوحده، this term طبعا نحن لأنه this is only، لو أخذت CIJ لوحده هو second order tensor، يعني 9 terms. لو بدي اخذ هي لوحده هو first order tensor، ولكن بدي اخذ اثنين سوا صار all of these هو first order tensor، لانه number of free indices هن only one هي I. لاحظ these are three members, three components, and this also three components, so this equal to this one, and that's why I put I and I. يعني حول x1 equal to c1 1 Z1 plus C12 Z2 plus C13 Z3. For I equal to 2 هيطلع second component. For I equal to 3 بيطلع third component. لاحظ أنا قلت الدمي indices all terms will be added. The free indices represent directly the component of the tensor. وين حطيتهم هون in expanded form لاحظ الإكس هو عبارة عن 3 component أو 3 أو tensor forms 3 terms, and these terms can be component, can represent stresses, can represent deformation, and so on. Another example, let's say for example we have AIJ equal to BIP G CGQ DPQ. لاحظ هون how many terms we have. لاحظ عندي PP and we have, say for example, P and Q. P repeated twice. This is a P and this is P. This is a Q and this is a Q. So P and Q are repeated twice, so therefore they are dummy indices. أنا عم بحكي على هالترم هذا صح؟ I does not repeated it's only once, and J only once. So therefore this term altogether هو tensor of second order. The number of free indices هن شو هو I and J. So this is second order tensor. Or and this can be equal to AIJ. This is I and J, so I and J. So therefore this tensor has 9 terms. If it's, say for example, in space, if it is in plan, so it has 4 terms. And this can be written, and I put I and J, P takes only 1, 2, يعني كأنه هو in plan. In expanded form will be as follows. So I'll put I equal, say for example, to 1. Right? And I and J equal to 1. So هيطلع عندي A1 1. Put I and J equal to 1. So therefore all values around the P and the Q will be summed. So therefore this will be, لاحظ احط هون ال B equal ال I equal to 1. فإذا and J equal to 1 هيطلع عندي A1 1. وبعدين نحط ال I equal to 1 and J equal to 2 هيطلع A1 2 and so on. فإذا هون لو حطيت ال I equal to 1 and the value over P and Q are summed, فإذا عندي أنا ال I and J equal to 1. فإذا عندي B1 1 C1 1 D1 1. وبعدين هلا اغير الفاليو اوف بي هتصير عندي بلس بي 1 2 او بي 1 1. خليني اغير الكيو ساي فور اكزامبل بي 1 1 سي 1 2 دي 1 1 بلس بي 1 2 سي 1 1 لانه هي اوفر اتس ان بلان. سو اي جي تيك ذا فاليو 1 اوف 2 1 and 2. طبعا انا حطيتها 1 and 2 not 1 2 3 لانه حيصير فيري لونج لاين يعني. فإذا B12 C11 D21 plus B12 C12 D22. فإذا this is A11. حطيت أنا ال I وال J equal to 1. وبعدين أحط ال I equal to 1 and J equal to 2 and in this way. وبعدين ال I equal to 2 J equal to 1 وبعدين I equal to J equal to 2. فإذا these are 4 terms. In plan لاحظ if it is in plan, so the I values of I and J take the value 1 2 1 and 2 and I and J do not repeat. Then I appears only once and J appears only once. So therefore this is free index and that's free index. So therefore number of free indexes equal to the order of the tensor. فإذا it is second order tensor ولكن in plan. In plan يعني كأني عم أقول 2 to the power 2 هي equal to 4. So this tensor has 4 components and in the expanded form this can be determined as well. اوكي شباب واضح؟ طيب
عطول بس يكون في عندي ضمي اندكس بعمل سميشن
صحيح.
وبمشي
هو لذلك أنا صحيح لذلك قلت إذا بترجع على الديفينيشن if you يعني read very carefully the definition of dummy indices لاحظ شو dummy indices when an index appears twice. it later هيمشي إذا الاندكس appears 3 times هتلاحظ انه this term does not have any meaning. يعني any index should appear only once or twice, not more than 2 times. لو هو يعني appears more than 2 فإذا هم في عندي this أو this term does not make any sense. and therefore مثل ما عملت أنا AI plus AIJ, right? Does not make any sense, right? فإذا if you read very carefully what is the definition of dummy indices, when an index appears twice in a term, لاحظ this is term, this is I appears twice. That index takes the value of its range, يعني whether in space or in plan, and the resulting terms are summed. Resulting term are summed. That is what I mean by when this is over this index, all terms will be يعني بس I takes the value of 1 فإذا هتصير عندي A11 A22 A33 all these terms will be summed over the dummy indices. لهالسبب بس كنت أنا موجود هنيك بأن ذات example اللي كنت عم بشرحه. لاحظ P and P فإذا أنا start حطيت ال I equal to 1 and لأنه النمبر in plan we have A11, A12, A21 and A22 because we have 4 terms, right? AIJ هو first second order tensor, but in plan it means 2 to the power 2. 2 to the power 2 هي 4. فإذا I takes the value 1 to 2 and J it takes the value of 1 to 2, right? فإذا التانوس هيكونوا A11, A12, A21 and A22. فإذا أنا حطيت هون 1 1 وبعدين خليت ال P equal to 1 وعملت أنا ال Q 1 to 2. بعدين لاحظ all will be summed. وبعدين حطيت أنا ال Q equal P equal to 2 وبعدها ال I وال J equal to 1. حطيت ال P equal to 1 وبعدين عندي حطيتها هذه 1 و 2 and so on. طبعا في terms هيكونوا إن the same. واضح ولا لا؟ فإذا هيكون the end will be in this way, right? ماشي الحال شباب صبية. We have another term, and this symbol will also be used in this course. Symbol we call it the chronicle delta, and is given by the term symbol delta and given delta ij. لاحظ delta ij of course it is a second order tensor. ليه؟ لأنه ال I هي free index وال J هي free index. Each of these indices appears only once, right? فإذا this is second order tensor. So by definition delta ij equal to 1 for I equal to J and equal to 0 for I different than J. Or another way, delta 1 1 equal delta 2 2 equal delta 3 3. And all delta ij هو second order tensor. So in space it's composed of 9 terms, right? يعني delta 1 1 delta 1 2 delta 1 3 delta 2 1 delta 2 2 delta 2 3 and so on. By definition, chronicle delta is defined by for I equal to J, component equal to 1, for I equal to J, difference in J, delta equal to 0. Or another way, لاحظ أنا في عندي delta delta 1 1 equal delta 2 2 delta equal delta 3 3 and delta 1 2 equal delta 1 3 equal delta 2 3 equal to 0, etc. All because it is second order tensor can be placed in matrix form. This is matrix form or unit vector, unit matrix, right? Right? So this is a second order tensor. ممكن نسميه أعطيه term a unit matrix or second order tensor وسميه أنا Kronecker delta. So this has 9 terms and the value of these terms are these. So we have 1, 1, 1, 0, 0, 0, 0, 0, 0. We have certain properties. Again, also this symbol will be used in subsequent chapters in order to derive certain equations or make verification of certain use. So this symbol will be used. Properties of this second order tensor اللي هو Kronecker delta. As you can see لاحظ delta ij aij delta ij شو قلت انا هذا؟ حدا في يقول لي هو هذا الترم مع بعضه. انه الاي هون عندي اياه شو هو؟ دم والجي هي فري. فاذا we have one free and x so therefore it is first order tensor. مظبوط ولا لا؟ صح؟ in expanded form فاذا قلت انا حثبت الفري اندكس وبلش غير الدمي اندكس from 1 to 3 or 1 to 2 depends whether it's in plan on space. What? فاذا in expanded form this will be all terms will be summed around the dummy indices. يعني بهالحالة this will be equal to A1 delta 1J plus A2 delta 2J plus A3 delta J delta 3J. Now put say for example if you put say for example J equal to 1 هيطلع first component مثل ما قلت this is first order tensor يعني it has 3 component. If you put say for example R J equal to 1 فإذا بصير عندي A1 delta 1 1 plus A2 delta 2 1 plus A3 delta 3 1. لاحظ delta 2 1 شو بتساوي؟ equal to 0. delta 3 1 equal to 0, right? So therefore كأني delta 1 1 شو بتساوي؟ 1. فإذا أنا any combination of these in the same way if you put J equal to 2 this will be equal to 0. This will also be equal to 0. So it will be the value of the second component will be equal to A2 delta 2 2 delta 2 2 equal to 1 so therefore equal to 2. Or another way one of the properties of this second order tensor Kronecker delta تصير عندي AI delta ij equal to equal to AJ, right? For J equal to 1 هيطلع first component. For J equal to 2 second component and so forth and therefore equal to AJ equal AAG A1 A2 and A3. And this can be لاحظ بس أعمل derivation of certain equation لو عندي أي محل AI delta IJ حاطة directly equal to AIJ without verification. This is the first properties of Kronecker delta second order tensor. Second properties, if we have AIJ delta IJ لاحظ بهالحالة الI هي dummy indices والJ dummy indices صحيح ولا لا؟ Because I repeated it twice and G repeated it twice صحيح؟ فإذا this is a zero order tensor or another way only scalar value, one value. Tensor composite of one value. So AIJ delta IJ equal to AII which is equal to لو جيت حطيتها in expanded form هخلي ال I equal to 1 وخلي ال J 1 2 3. فإذا A11 delta 11 A12 delta 12 plus A13 delta 13 وبعدين بعدين عم بعمل بلس. ليش؟ لأنه بوث هن dummy indices. فإذا نحط ال I بتساوي 2 وبعدين غير الجي from 1 to 3 وبعدين نحط ال I equal to 3 but all summed. This is a plus and this is a plus. So هيطلع عندي only one value. لاحظ لو بعمل simplification A11 دلتا 11 تساوي A1 صح. لاحظ دلتا 12 equal to 0 دلتا 13 equal to 0 دلتا 21 equal to 0 delta 23 equal to 0. So all these 0. So we will be left delta 11 equal delta 22 equal delta 33, which are equal to 1. So the result of this is A11 plus A22 plus A33 in as an additional notation. This is equal to AIR. إذا أنا لو طلع عندي أي محل AIJ delta IJ any terms with the canonical delta directly I will say this is equal to AII or AIJJ because this does not change the. If you change the letter index, it does not change the meaning of the term, right? Any questions? واضح ولا لا؟ ايه يا شباب؟ طيب بعدنا
ايوه
خمسة.
واضح دكتور.
صعبة؟ لحد هلا بعدنا عم نحكي بشيء سهل، صح ولا لا؟ Another symbol, and I will continue this symbol and then I will stop. We have what we call it. We know what we mean by vector cross product, right? Say, for example, we have V1 scalar V2 cross V3 بسميه vector cross product of three vectors. طبعا يعني this can also be represented as indicial notation. We call it the permutation symbol. So in order to express the cross product A cross B, sorry, box product, I make a mistake, a vector cross product اللي هو A cross B. cross product vector هو اللي هو البوكس فيكتور، box product vector اللي هو scalar and then vector. So cross product of two vectors can also be represented as indicial notation by introducing a third order tensor اللي هو epsilon IJ, known as permutation symbol or alternating tensor, because لاحظ this symbol of this tensor, this is tensor, it has three free vectors, so therefore it is a third order tensor. Sorry, it is a third order tensor. يعني if it is in space, so it is 3 to the power 3. This represents 27 terms or 27 numbers. Properties of this third order tensor are as follows. It is defined as epsilon ijk equal to 1 if the values of ijk are or form an even permutation of 1, 2, 3. What I mean by even permutation, يعني أنا عندي لاحظ 1, 2, 3 in anti-clockwise direction in the same way. يعني appears in the same sequence whether clockwise or anti-clockwise. لاحظ 1, 2, 3 يعني أنا في يقول epsilon 1, 2, 3 equal to 1. epsilon 2, 3, 1 كمان equal to 1. epsilon 3, 1, 2 كمان equal to 1. This term epsilon ijk equal to 1 minus 1 if they do not form an even permutation or odd, بسميها odd permutation of 1, 2, 3. Odd permutation يعني say for example in this way, يعني this is clockwise, anti-clockwise, and this is clockwise. So this is say for example it can be 3, 2, 1, 2, 1, 3, or 1, 3, 2. If it is in this form, هي بسميها any odd permutation. if it tries to rotate in the clockwise direction, the value of this يعني في يقول epsilon 3 to 1 بتساوي minus 1. epsilon 2 1 3 كمان بتساوي minus 1. This symbol أو this value equal to 0 if the values of I, J, K are not form permutation of 1 to 3, or if 2 or more and this is repeated more than once. يعني في يقول أنا epsilon 1 1 2 هي بتساوي 0. epsilon 1 2 1 to 2 بتساوي 0. epsilon 3 3 3 كمان بتساوي 0. If it appears more than once, so it appears equal to 0. هتصير بتساوي 0. فإذا this, as I said, this is forms 27 terms, and these terms can be equal to 1, minus 1, or 0, depends on whether these 3 and this is form an even permutation, odd permutation, or we have repetition of I, J, or K in the term. How this can be used for to represent cross product as indicial notation. احنا بنعرف انه A cross B هو عبارة عن فيكتور مظبوط. فإذا لازم تساوي certain vector C. In indicial notation it will be written in this form. We have to be consistent. يعني epsilon I J K A J B K. لاحظ ال I هي free to therefore وهون dummy, so all terms will be summed over J and K, so therefore this should be CR. يعني هون should be مش هحط CK غلط CK لأن لازم أحط الدمي انديس هون الفري اندكس هون لازم تكون فري اندكس. لاحظ if you put say for example these, if put I equal to 1 and all terms will be summed over J and K هيطلع الفيرست component. لو جيت عملتها هتطلع عندي this is C1. لاحظ this is equal to 0 ليش؟ لأنه ال I, J or K repeated more than once. 1 1 repeated twice, so this is 0 0. This is كمان هادي 0. لاحظ this is 1 2 3 0 1 2 2 0. لاحظ epsilon 1 2 3 equal to 1. 1 appears twice, so this is 0. مظبوط ولا لا؟ And 3 appears twice, so there is 0. 1 3 2 1 3 2 equal to minus 1. So therefore the resulting first component of this vector is equal to A2 B3 minus A3 B2. Exactly similar to لو أنا بدي أعمل cross product. لاحظ first component A2 B3 minus B2 A3 هو ذاته التعب. مظبوط ولا لا؟ فإذا بدل ما أنا يحط 3 terms في يحط epsilon I J K A J B K هو represents 3 terms with component equal to by changing the value of the term, right? Box product can also be represented in as indicial notation A cross B scalar C. طبعا this is scalar value مثل ما بنعرف صحيح. In indicial notation should also represent scalar value. فإذا represented by epsilon I J K AI B K C K. لاحظ 3 vectors I will J will K in this term شو هو؟ هن dummy indices. فإذا this in the same way if you add all these values, consider say for example I J equal to 1 وبعدين change K from 1 to 3 and all these values, and then consider I equal to 1 and J equal to 2, and then sum all terms over K and so on, so you get the same scalar value. So you have addition of 27 terms because this is A, and replacing, say, for example, epsilon ijk by its value, whether 0, 1, minus 1, or 0, so you get the same value if you get it, say, for example, in this one, right? So these terms or symbols represent a certain type of tensor and will be used in the course. Any questions? أي سؤال؟ طبعا بقول لك سهلة. هنزل لك الكورس نوت and I will stop now for today. Right? Any questions? ايه يا شباب؟ هنزل لك الكورس، هنزل لك الكورس نوت وبعدين for each session, because we are not at the universities, يعني I will leave 10 minutes at the start of each session for any questions, right? So I will upload this chapter so you can read it, and at the start of next session وهيكون انتين هيكون Monday معاك ولا Wednesday؟
Monday.
لو في عنا أي question ممكن at the start of first 10 minutes you can ask any questions you want, right? Okay. واضح؟ واضح شباب صبايا؟